Hey class, welcome back, and we're taking a look at the second mini lesson here in Unit C, which is taking a look at the mean of grouped data. So we looked at the mean of ungrouped data, and we really didn't define that before. Ungrouped just simply means that all the numbers are shown. You see all the numbers. They might be in one column of a spreadsheet, but they're not grouped in any way. So all of these examples that we looked at here are ungrouped data where you see all the actual numbers. Now, let's go back actually to page, I think it's about page 7 or so, where we're talking about the age distribution of people in Red Deer. This is what we call group data. And so you're not seeing then all 100,000 people, right? We got, how many people do we have in total here? Almost 100,000 here, people. So we're not seeing a list of all 100,000 people. What we've done is we've put them into classes, which is what we did in Unit G. And so you've got your classes here, and then you've got your frequencies, and then you've got your relative frequencies, F over N. One thing that we could put in here, and we will need if we were to calculate averages here, or grouped means, is a class mark. So the class mark from 0 to 4-year-olds is 0, 1, 2, 3, 4. The middle number is 2. And then 5, 6, 7, 8, 9, the middle number is 7. So that's the class mark. So we're going up by 5, so this would be 12. This would be 17, and so on all the way up. So those are the class marks, and we'll use an M to show that, just as we did back in Unit G. And then we have F for the frequencies. Now here's the thing, is when it comes to actually calculating these particular, doing calculations with 100,000 numbers like this, take a look at the class from 0 to 4 years old, these folks right here. And I guess I'm just looking at the females here. I could take a look here at the totals, but it's just easier to take a look at the females here. So we'll focus in on the 48,000 females. And what I'd like you to notice then is that because our infant mortality rate is fairly small in Red Deer, it means that you've got probably close to just about as many 0-year-olds, that is newborns, as you have 4-year-olds. So when we're talking about coming up with an average age, then you could say, well, instead of thinking of each kid there and what their age is rounded to the nearest year, we could say, you know, we have probably about the same number of newborns or 0-year-olds, kids in their first year, as we have 4-year-olds. And so it's kind of like that they average out to a bunch of 2-year-olds, just like the 1 and 3-year-olds average out to 2-year-olds. And of course the 2-year-olds are 2-year-olds. And so you can think of these as being 2,361, in this case they're girls, 2-year-olds. That is useful if we want to ask the question, well, what's the average age of all of the females? Then we can just take a look then at the class mark and the frequency and use that in our formula to come up with the average age. We could do the same with the males, or we could do the same with all of them. So let's go back then, and I'm just going to get rid of a bunch of this marking here because we can use this later. All right. So we'll go back here then and say for the mean of group data, the formula that we'll use here is the mean is equal to the sum of the MFs divided by the N's. So the X's then for the ungrouped data are the actual numbers, the actual ages of the people here. But when they're grouped together, what we end up with is class marks, usually the midpoint of classes, and then the frequency, how many are in each class. So let's take a look at the data that we have been using, the ages of the 50 people, here's the 50 numbers, 14 up to 97. And actually, this looks really similar to the stem and leaf that you did, right? But what we've got here then is a 14-year-old, a 21-year-old, a 32, 249s, and 7 in the 50s, and so on like that. When you take a look at these particular values here, especially when you get into the classes where there's a large number of people. So here's the 60s, and there's 10 of them. What you can see is you've got some which are low, 61s, and you've got some which are high. You've got 68 and 69s. You can kind of think of a 61 and a 69 averaging out to somewhere close to the middle, right? A 65. And similarly then for the 62s and the 68s and so on like that. So the class mark here, the middle of this class then, is the average between 60 and 69. 60 plus 69 divided by 2 gives you 64.5. And so what we could do is we could think of all of these 60s then as being rewritten as, instead of 10 uniquely different numbers between 60 and 69, 10 64.5s. Because you got some high and some low, and they balance out. Same with the 50s, same with the 40s, the 30s, the 20s, and so on with each of these. Now, you might look at this and say, well, okay, 14 is a little different from 14.5. 21 is quite a bit lower, and so on. And these 44.5s are quite a bit lower than the 249. So how does that work out? What we're going to see actually is that the mean, the grouped mean here, turns out to be really close to the ungrouped mean. So what we can do here is we've rewritten all of these values up here as midpoints. And then we could say, so what that means then is I've got 14.5. So this is my midpoint or class mark, and this is my frequency. So there's one of those, one in the 20s, one in the 30s, two in the 40s, and so on like that. Those are the same two columns that you saw back in Unit G. And so we can go back there and have to, what page was that on? So this is right in here. Good. So this is what we've basically done here, is we've created these two columns here. Okay? So that's the first step in coming up with a grouped mean. Then what we do is we just multiply each of the class marks by its frequency to get an MF value. And then we sum them up and divide through by n. So this is what we've done. That's what we've done down here. So 14.5 times 1 plus 24.5 times 1, and so on, all the way up to the last one, which is 94.5. That's a mistake there. 94.5 times 6. And then you divide through by the n, which is 50. What's really important to note here is that this n is not the number of classes, which in this case is just 9. That would give you an error. This is the total of the frequencies. So the sum of the frequencies is equal to your n. Now look what happens. The number that we get is 69.9. When we did this back a few pages, the ungrouped mean, when we actually had all of the numbers together shown, came to 70. They're almost identical, even though we've changed all of these to midpoints here. And that's because some will be high, some will be low, and so on, but they'll tend to average out. So the ungrouped mean then is 70. I'm going to do one more here then, and then I'm going to leave this one here for homework, and we'll take that one up in class. But let's take a look at number 7 here. So this is talking about here, oh, sorry. Let's back up here and say, you can do this using a table. So you've got an M you've got an F. All we have to do is multiply each one. So 4.5 times 0 is 0. 14.5 times 1 is 14.5. And so on like that. 24.5, 34.5. And then, let's see, what do we got after that? 89.0. 54.5 times 7 is equal to 381.5. And we've got 645. 645, and then we've got 894, and then we've got, oops, sorry, I've got to back up here just a bit. So 645, and then we have an 841, and then an 894, and then finally we've got a 567, and that's going to sum up here to 3495, and then we divide that by 50, and that's where you get your 69.9 from. So that's how you do that with a table. All right, I'm going to actually assign the next one here for homework. Let's take a look at this one, which is the ungrouped mean for the classes of the weights of the Business 306 students. So in this particular case then, what we're going to do is the first class is we use Sturgis method to come up then with class widths of 20. So the first one is going to be 80 to 99. And by the way, these are not in order. Here's your lowest number, which is 82. And your highest number then is, I think it's 190. Oh, here's a 200 right there. Is that the highest? I think so. All right, so the class marks then, which is the midpoint of each of these classes, is going to be 89.5. And then we're going to be going up by 20s. So 109.5, 129.5, 149.5, 169.5, and 189.5. The frequencies are, you'd have to go through and actually count each of these, but there's two which are less than 99. There's the 82 here, and then there's the 98 there. So there's two of those. There's 5 from 100 to 119. There's 5 again in the next class, and then there's 9. There's 4, and there's 3, and that sums up to 28. Now what we do is we multiply. Let me change colors here. So 89.5 times 2, just going across each row, is going to give you 179.0. And then we've got 109.5 times 5 gives you 547.5, and then we've got 647.5, 1345.5, 678.0, and 568.5. And those sum up to 3966. So the mean then is going to be equal to the sum of the MFs over N, which is going to be 3966 over 28, which is 141.64. So the average weight then of the Business 306 students is about 142 pounds. All right, that leaves you this guy here. And that's going to be done for homework. The difference in this particular one here Nope, that's fine. Okay. The formula above is used for calculating the mean for group population data. An equivalent formula then for sample data is x bar is equal to the sum of the mf's over n. So same substitutions as we had before, is we would have a little n instead of a big N, and then you'd have an x bar on the left-hand side instead of a mu. But otherwise, the calculation is exactly the same. Now, take a look at this last one down here, which is the weighted mean. And the point in this is to say that actually you've been calculating weighted means probably for years. So if somebody asks you, how well are you doing in a class, what you're calculating is a weighted mean. So let me show you how this works in terms of the marks here. So what's the average grade, or what's the grade that the person has here? What you might want to do, by the way, is just stop it at this point and see, can you actually apply the mean formula, the grouped mean formula, to see if you can figure this out. So just pause it at this point and then we'll pick it up. Okay, I'm going to assume that you've done that. And this is how the thing works, is you can say that the mean is equal to the sum of the f's over n. Now, one thing we could do is we could bring that n up. So it would be the sum of the, the sum of the m's times the f over n's. And that's equivalent. And the f over n's then are relative frequencies, which are the percentages. So these are your f over n's. And then you can think here of this as being your m in this case. Now, it's not really a midpoint of a class or a class mark, but it is that we'd use it the same sort of way. So we would go like this. The mean is equal to 65 out of 80, 65 out of 80, times the relative frequency, which is 25%, plus 70 over 100 times 0.25, plus 18 out of 20 times a weighting of 15%, and then plus 90 over 100 times 35%, and that comes out to be, I've got that figured out here somewhere, 82.81%. Really, it's actually 0.8281, but it's 82%. Then 83% is what the person has in their mark. So the point being is that you've used weighted means before when you've calculated what your grade is in a particular class. So that's where we're going to end it here.